A fifth of the global warming that has occurred in the past 150 years has been missed by historical records due to quirks in how global temperatures were recorded, a new NASA study has claimed. Experts say the controversial study helps explain why projections of future climate based solely on historical records estimate lower rates of warming than predictions from climate models. Scientists have known about these quirks for some time, but this is the first study to calculate their impact. They're quite small on their own, but they add up in the same direction, said Mark Richardson of NASA's Jet Propulsion Laboratory, the lead author of the paper. We were surprised that they added up to such a big effect. This study applied the quirks in the historical records to climate model output and then performed the same calculations on both the models and the observations to make the first true apples-to-apples comparison of warming rates. With this modification, the models and observations largely agree on expected near-term global warming. The results were published in the journal Nature Climate Change. Correcting for these biases and accounting for wider uncertainties in data forcing based on recent evidence, we infer an observation-based best estimate for TCR of 1.66 degrees Celsius, with a 5 to 95% range of 1.0-3.3 degrees Celsius, consistent with the climate models considered in the IPCC Fifth Assessment Report, the researchers concluded. The Arctic is warming faster than the rest of Earth, but there are fewer historic temperature readings from there than from lower latitudes because it is so inaccessible. A data set with fewer Arctic temperature measurements naturally shows less warming than a climate model that fully represents the Arctic. Because it isn't possible to add more measurements from the past, the researchers instead set up the climate models to mimic the limited coverage in the historical records. The new study also accounted for two other issues. First, the historical data mix air and water temperatures, whereas model results refer to air temperatures only. This quirk also skews the historical record toward the cool side, because water warms less than air. The final issue is that there was considerably more Arctic sea ice when temperature records began in the 1860s, and early observers recorded air temperatures over nearby land areas for the sea ice-covered regions. As the ice melted, later observers switched to water temperatures instead. That also pushed down the reported temperature change. These quirks hide around 19% of global air temperature warming since the 1860s. That's enough that calculations generated from historical records alone were cooler than about 90% of the results from the climate models at the Intergovernmental Panel on Climate Change, IPCC, uses for its authoritative assessment reports. In the apples-to-apples comparison, the historical temperature calculation was close to the middle of the range of calculations from the IPCC suite of models. Any research that compares modeled and observed long-term temperature records could suffer from the same problems, Richardson said. Researchers should be clear about how they use temperature records to make sure that comparisons are fair. It had seemed like real-world data hinted that future global warming would be a bit less than models said. This mostly disappears in a fair comparison,